Myself, Nishu Singh from FIBSCCS, Division F, roll number FF41. The presentation is about exponential distribution. In this presentation, we are going to see what is exponential distribution, mean variance and standard deviation of exponential distribution function, properties of exponential distribution, and example of exponential distribution. What is exponential distribution? The exponential distribution is a probability distribution that models the time between events in a process where event occurs continuously and independently at a constant average rate. It is often used to describe the time it takes for a specific event to occur. PDF is given as f of x is equal to 1 by theta into e raised to minus x by theta, where x is greater than equal to 0 is equal to 0 otherwise. Now we will see about mean, variance and standard deviation of exponential distribution. First is mean, also called as expected value. The mean mu of an exponential distribution is given by the reciprocal of the parameter lambda. Therefore, mu is equal to 1 by lambda. Second is variance. The variance sigma square of the exponential distribution is equal to the square of the reciprocal of lambda. Therefore, sigma square is equal to 1 upon lambda square. Third is standard deviation. The standard deviation sigma is the square root of the variance. Sigma is equal to 1 by lambda. Exponential distribution function f of x is equal to 1 minus e raised to minus x by theta is equal to 0. X is less than equal to 0 is equal to 1 minus e raised to minus x by theta, where x is greater than 0. Property of exponential distribution. Property 1. A random variable x is memoryless if probability of x greater than s plus t or x is greater than f is equal to probability of x greater than s, where st is greater than equal to 0. From the definition of conditional distribution, we can write probability of x greater than s plus t or probability of x greater than t upon probability of x greater than t is equal to probability of x greater than s. Property 2. If x1, x2 or xn are independent identical distribution exponential random variables each with mean 1 by lambda, then y is equal to x1 plus x2 plus dot 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 xn will have a gamma distribution with parameters n lambda. The PDF is given by f of y is equal to lambda e raised to minus lambda x into lambda x raised to n minus 1 upon n is equal to lambda e minus raised to lambda x into lambda x raised to n minus 1 upon n minus 1, and ey is equal to n up by lambda, v of y is equal to n by lambda square. Here is a real-life example of an exponential distribution. A trucker drives between a fixed location in Los Angeles and Phoenix. The duration in hours of a road trip has an exponential distribution with parameter 1 by 20. Determine the probability a round trip A takes at most 15 hours. Therefore, probability of x less equal 15 is equal to 1 minus e raised to 15 by 20 is equal to 0.5276. B takes between 15 and 25 hours. Therefore, probability is equal to 15 less equal x less equal 25 is equal to 1 minus e raised to minus 25 by 20 minus 1 minus e raised to 15 by 20 is equal to 0.1859. Some real-life situation of exponential distribution. First is call duration. Second, change kept in pocket or purse. Third, lifespan of electronic gadget. Fourth, purchasing flight tickets. Fifth, shoppers at a shopping mart. Sixth, time that an interviewer spent with a candidate. Thank you.